Imagine that you're on a warm coastline some 48 million years ago by the ocean. The planet did not look like it does today. It was hotter, sea levels were different, and in certain regions, such as what is now Pakistan, there were river systems, coastal lagoons, and estuaries where fresh water mixed with the sea, perfect places for ambushes. And there, among the mud and vegetation, appeared Ambulocetus natans. The name already gives you a clue. The whale that walks and swims. But don't be misled by the word whale. This was not a huge, gentle animal floating in the ocean. This was something else, a heavy, amphibious predator with a wolf-crocodile appearance, seemingly designed to make you question everything you thought you knew about how a whale is supposed to look. The first thing that would have caught your attention was its robust body, with well-developed legs. It was not a fish, it was not a dolphin. It had limbs with strong bones capable of supporting it on land. But it was not a normal terrestrial mammal either. The shape of its skeleton suggested that its real life took place in the water, or at least on the boundary between land and water. On solid ground, it probably was not fast. Instead, one imagines it with an awkward gait, like those animals that can walk, yes, but are not built for long chases. Its power lay elsewhere, ambush. A heavy body is a problem for running, but it can be an advantage when you use it as a battering ram, as an anchor, as mass to dominate prey in a confined space. Now, where it truly became impossible was in the water. Reconstructions and analyses of its bones suggest that it swam in a way that feels eerily familiar today. It resembled the swimming style of a giant otter or even certain crocodiles, using its body to propel itself with undulating movements and with powerful hind legs contributing thrust. But here comes the key point. Ambulocetus was not a strange evolutionary whim. It was a sign that something gigantic was happening in the history of life. The ancestors of whales were leaving the land. Think about it for a second, because it sounds insane when said out loud. Cetaceans are mammals completely adapted to the sea. They breathe air, nurse their young, have warm blood, and yet they live like fish. That did not happen by magic. It happened through a chain of intermediate steps, and Ambulocetus was one of those steps that feels like a mistake until you understand the context. Why would anyone trade land for water? For the same reason that explains almost everything in biology: food and opportunity. Coastal zones are natural supermarkets. There are fish, there is carrion, there are animals that come to drink, there are birds, there are reptiles, and if competition on land was fierce, the water's edge opened a door, a place where a mammal with certain advantages could become the ruler of the corridor. And Ambulocetus had clear advantages. Its skull and dentition painted it as a serious predator. It was not a strange herbivore, it was not a filter feeder. It was an animal equipped to bite, hold, and tear apart. Imagine a bite capable of grabbing slippery prey, fighting with it in the water, and not letting go. In an estuary, that was a death sentence. Another fascinating aspect is hearing. In modern cetaceans, the way they hear underwater is deeply specialized. But in early forms like Ambulocetus, that transition was just beginning. That is to say, it was an animal entering a world where sound travels differently, where vision becomes less reliable because of murky water, and where sensing vibrations can be just as important as seeing. Evolution here was tuning sensors for a new environment. Meanwhile, the body told another story. The bones of its limbs and its overall structure suggested that it was not an occasional visitor to the water. It was its hunting ground. If it could walk, it was to move between pools, sandbanks, and shorelines, to change hiding spots, to surprise from a different angle, to reposition itself. In other words, Ambulocetus did not need to be the king of the land, nor the king of the open sea. It was enough to be the perfect monster of the edge. Now, what earns it a place in this ranking of creatures that should not have existed is not just its appearance. It is the idea that at that moment in time, nature was producing an animal that today feels contradictory. A whale with legs, a mammal that still looked like a terrestrial predator, but that was already committed to the water. And there is something more, almost cinematic, imagining the future from that point, because Ambulocetus was not the end of anything. It was part of a lineage that over time let go of the land. The legs transformed, the body lengthened, the tail took center stage, the nostrils migrated upward, until the strange amphibious animal became a fully ocean-dwelling inhabitant. But at that moment, in that Eocene estuary, the scene was simple and brutal. Murky water, silence, and a predator waiting. Perhaps motionless, with just its head above the surface. Perhaps hidden among the vegetation, measuring the exact moment. And when something came close, the attack did not have to be elegant. It had to be final. 2. Titanoboa cerrejonensis. Now we move from this is weird to this is downright unfair, because Titanoboa cerrejonensis was essentially what happens when a boa constrictor is given evolutionary permission to grow without limits, in a world that, for a while, allowed it. We are talking about a gigantic snake from the Paleocene shortly after the extinction of the non-avian dinosaurs. This detail matters. When most people think of prehistoric monsters, they imagine the Cretaceous with tyrannosaurs and velociraptors. But Titanoboa lived later when the planet was reorganizing itself. And in that reorganization, empty spaces appeared, missing predators, vacant niches, and a tropical climate that in human terms would have been almost suffocating. The story becomes even more cinematic when you place yourself in the setting, what is now Colombia, in the region of the Cerrejón coal mine. That is where the fossil material that allowed this animal to be described was found. And it was not the typical complete, pretty skeleton for a museum. It was what usually turns up with snakes, mainly vertebrae, many vertebrae. But large enough for the message to be immediate: this is not a normal snake. Why do vertebrae matter so much? Because in snakes, the backbone is the body. Its shape, size, and robustness allow you to estimate total length with considerable confidence. And with Titanoboa, those estimates went into territory that our brains struggle to accept. It is calculated to have reached over 12 meters in length, with some estimates pushing even higher. For comparison, a large anaconda is already impressive, but this was another league. It's not a big snake. It's a snake that, if you see it stretched out, looks like a rail car. And it wasn't just long, it was thick. Total mass is estimated in the hundreds of kilograms, possibly approaching a ton depending on the model. That changes everything, because a snake of that size does not behave like an ordinary snake. The rules of its bodily world are different. Moving the body costs more, heating the body costs more, supporting itself costs more. So the inevitable question is, how could it exist without becoming a biomechanical disaster? The answer is twofold: environment and strategy. First, the environment. Snakes are ectotherms. They depend on the environment to regulate their temperature. A giant animal needs to keep its metabolism running, and in cooler climates, a snake like this would be slow, vulnerable, almost unviable. But the tropical Paleocene of that region was warm and humid, with a rainforest that, judging by plant fossils, resembled an early Amazon, but on a planet probably hotter than today. And here something fascinating appears. Titanoboa is not just an impressive animal, it is also a kind of fossil thermometer. Because if such a snake could thrive, it suggests that the environment had temperatures capable of sustaining a giant ectotherm with reasonable efficiency. It is as if the ecosystem itself were saying, yes, heat here is part of the system, not an accident. Second, strategy. Titanoboa did not need to be fast. In fact, it is very likely that it was not, at least over long distances. A body that massive works best with the oldest predatory style on the planet: ambush. Imagine the scene in a swamp, a slow river, a dark lagoon. In that environment, size is a psychological weapon, but also a physical one. A huge snake can wait semi-submerged, almost invisible except for slight ripples. And when something comes close, the first phase of the attack is short and explosive, a bite to secure the grip and immediately the body wrapping around like a living hydraulic press. What could it hunt? That ecosystem hosted a very interesting variety of prey: large fish, reptiles, and above all, a supporting cast that seems pulled straight from a tropical monster saga, ancient crocodiliforms and giant turtles. And when I say giant turtles, I don't mean a large river turtle. I mean sizes that make a normal bite insufficient. You need real strength, the ability to control a heavy, resistant prey. A snake like Titanoboa could do something that is pure terror for a prey animal, dominated by volume. In water or mud, the snake's body has more support, less friction, and its weight becomes an advantage. The prey cannot lever itself free. It cannot run. It cannot maneuver. And if it was a large reptile living near water, the risk was constant. Any crossing, any pause to drink, any moment of distraction could be the end. Now, there is a common myth about constrictor snakes, the idea that they crush until bones snap like in a movie. In reality, constriction works more by cutting off circulation and collapsing vital functions. But in the case of an animal of such enormous size, the available pressure was so high that even without trying to break bones, the overall force could be devastating. And most importantly, it didn't need to kill quickly through pursuit. It only needed to secure the grip and let the body do the rest. What makes Titanoboa one of those creatures that should not have existed is not just its size. It is the full context package. It appears at a moment when the world was trying to reset after a mass extinction. Mammals had not yet fully taken control of the large predatory niches. Reptiles, especially in tropical environments, still had enormous room to become giants. And in that gap, a snake could become the kind of predator we now associate more with fantasy than with real biology. And there is one detail that I find the most unsettling of all. A giant snake does not need to roar or bare its teeth like a dinosaur to impose presence. Its threat is silent, passive. It lies in the possibility that the water is, in fact, territory controlled by an animal you cannot see until you are already inside the problem. Titanoboa was a reminder that the extinction of the dinosaurs did not eliminate the possibility of monsters. It only changed the cast. And for a time, in that Paleocene jungle, the ultimate monster had no legs or claws. It was an endless Posvanok column that turned the river itself into a trap. 3. Jaekelopterus renaniae. If dinosaurs are your thing, this monster will throw you off because Jaekelopterus renaniae did not live in the world of tyrannosaurs. It lived much earlier, in the early Devonian, when life on land was still tentative and the real spotlight was underwater. And the worst, or the best, depending on how you look at it, is that we are not talking about an aquatic dinosaur or a huge fish. We are talking about an arthropod, a bug with an exoskeleton, a distant relative of arachnids and horseshoe crabs. A member of the Eurypterids, those animals often nicknamed sea scorpions, although to be fair, they were not true scorpions. Now, the detail that turns it into a historical nightmare. Jaekelopterus is among the strongest candidates for the largest arthropod ever known. The most commonly cited estimates place it around 2.3 to 2.6 meters in length, and the reason this gets so much attention is almost cinematic. Part of the evidence comes from an enormous frontal claw, a fossil Chalicotherium found in Germany in early Devonian deposits. To give you a sense of scale, when an arthropod reaches those sizes, it stops feeling like a big insect and starts feeling like a real predator. Not because of aesthetics, but because of mechanics. A large exoskeleton is armor. A pair of appendages designed to grab and cut become tools of butchery. And if, on top of that, you are in an environment where most vertebrates were still learning how to dominate the water, the balance of power can turn very ugly for anything swimming nearby. The world of Jaekelopterus was a warm one, with seas and coastal environments and with zones that could be estuarine, brackish or freshwater, depending on the location. The fossil record of J. renaniae points to freshwater to brackish environments in the region of Rhineland, Germany, which already breaks a common assumption. It was not necessarily a monster of the open ocean, but a terror of shallow waters, lagoons, deltas, and coastal systems where ambush was easier. And here comes something key to understanding why this should not have existed in our modern mindset. Today, large aquatic predators tend to be vertebrates. But in the Paleozoic, before that division was locked in, there were moments when certain arthropods occupied the role of apex predators. The Eurypterids were, so to speak, an early version of armored hunters, capable of dominating their environment. How did Jaekelopterus hunt? The typical sea scorpion image can be misleading because one imagines a venomous stinger and an attack like that of a modern scorpion. But the main weapon here was not a stinger, it was the chelicerae, those frontal appendages that functioned like claws. In the case of the pterygotids, the group to which Jaekelopterus belongs, those chelicerae were truly large and specialized for capturing prey. And this is not just intuition. Studies analyzing the shape and stress patterns of these structures support the idea that some of these Eurypterids were adapted to attack relatively hard prey, including armored fish. In the Devonian, fish were not modern fish with a different look. There were extremely strange forms, including armored fish like placoderms, with bony plates that functioned as helmet and shield. A predator capable of dealing with that needed strength, grip, and control, and here Jaekelopterus fits perfectly as the kind of creature that turns an evolutionary advantage into outright abuse. Another often underestimated factor is the importance of vision. In several eurypterids, and especially in closely related pterygotid lineages, the evolution of advanced visual systems has been discussed. In relatively clear waters or short pursuit hunts, seeing quickly and accurately can be the difference between eating and missing out. Jaekelopterus did not need intelligence in a mammalian sense. Efficient sensors and a body built to close distance at the right moment were enough. Now let's talk about the B side that makes all of this even stranger. Growing that large with an exoskeleton comes at a cost, and it is called molting. Arthropods do not grow the way we do. They grow by changing their armor. During molting, for a time, the animal is more vulnerable. Protection is not at its peak. The body is in transition. So how does a giant predator survive with a periodic phase of vulnerability? Partly through behavior, seeking shelter, choosing safe times and places, and minimizing risk, but also through a simple ecological reality. If you are the dominant predator in your area, even your weak phase is less dangerous than the normal phase of almost anything else. Even so, Jaekelopterus was not invincible or eternal. These creatures depended on a specific set of conditions: suitable ecosystems, oxygen levels, competition, available prey, and an environmental dynamic that did not last forever. Over time, the world changed. Aquatic vertebrates diversified, and the role of giant arthropod in charge became increasingly rare until it disappeared. But in its time, imagine it: a shallow channel, an ancient estuary. Strange fish moving like shadows, primitive plants along the shore, and suddenly the water breaks from below. A segmented, armored body appears, with appendages not designed to intimidate, but to grip. There is no roar, no warning, only mechanical force, designed to end the story quickly. 4. Quetzalcoatlus northropi. If I asked you what the largest flying animal that ever existed was, your mind would probably conjure up an image of a giant eagle or an enormous bat. But Quetzalcoatlus northropi was neither of those. It was a pterosaur, that is, a flying reptile from the Mesozoic, not a dinosaur, although it lived alongside them and was part of the same world. And the first thing that makes Quetzalcoatlus feel impossible is its scale. Some wingspan estimates hover around 10 to 11 meters, while others place it even higher, close to 11 to 12 meters. Either way, we are talking about an animal comparable in size to a small airplane, but made of bone, skin, and muscle, and presenting a major contradiction. The first idea is simple. To fly, you need lightness and efficiency. The second idea is also simple. To be enormous, you need structure and strength. In modern nature, those two things rarely go well together. But pterosaurs played by different rules than birds because their wings were not rigid feathers. They were membranes supported mainly by an enormously elongated finger, like a fourth finger turned into the mast of a sail. And that architecture allowed something that sounds absurd: a gigantic animal that could still fly, or at least that evolved to do so. Quetzalcoatlus lived toward the end of the Cretaceous, and its most famous remains are associated with the Javelina Formation in the Big Bend area of Texas. The first key discovery is attributed to Douglas Lawson, a graduate student at the University of Texas at Austin in 1971, and the name Northropi was given in honor of John Knudsen Northrop of the Northrop Aeronautics Company, in addition to the nod to the Mesoamerican god Quetzalcoatl. And here comes something many people do not expect. The flight environment was not windy seaside cliffs. It was more like a floodplain environment with meandering rivers, sediments, wooded areas near water, and a wide variety of fauna around. In Big Bend, fossils of fish, turtles, crocodiles, small mammals, dinosaurs, and pterosaurs like Quetzalcoatlus have been found. But the detail that makes it even stranger is how it behaved on land. For years, the popular image of the giant pterosaur was, it lives in the air and lands once in a while. And with Quetzalcoatlus, that idea had to be revised. Evidence and modern reconstructions describe it as an animal that spent a lot of time on the ground, walking on four limbs with a very particular gait. It is even emphasized that when its wings were folded due to its size, they could touch the ground, already giving you a sense of the sheer scale of the creature standing in front of you. The comparison used by many science communicators and museums is very vivid, something like a gigantic stork, but on 4 legs with a long neck and a long toothless beak. The idea is that rather than being a flying fisherman, it may have been an opportunistic hunter on land, stalking small or medium-sized prey, patrolling shorelines, channels, wetlands, and open plains. And that completely changes the kind of fear it inspires. Because it is not just something enormous flying overhead, it is something enormous that can be walking near the water, like a silent predator, and that also has the option to take off if the situation demands it. That combination feels unnatural, almost as if you mixed 3 animals into one, a wading bird, a condor-like glider, and a reptile. In fact, in the package of recent studies and reconstructions presented in 2021, in a series of publications associated with the Society of Vertebrate Paleontology, this is emphasized precisely. Its geological and ecological context, its anatomy, and how it moved both on land and in the air. Now, to make it even more impossible, think about takeoff. An animal with wings that large could not simply run like an ordinary bird and lift off. Among pterosaurs, the idea of quadrupedal launch is widely discussed, using the front limbs, which are actually wing arms, as a powerful push to catapult itself upward. And in a giant, that strategy makes sense because it turns takeoff into a brief burst of power rather than a long, vulnerable run. Modern reconstructions often insist that Quetzalcoatlus was adapted to move on the ground and to take off without needing a perfect runway. But we also have to be honest about one thing. The exact mass and real flight performance are still subjects of technical debate. It is not the same to imagine it as an ultralight animal of hollow bones and membrane, as it is to imagine it as something too heavy to stay aloft. That is why, depending on who you read or which reconstruction you look at, you will find differences in the numbers. What remains stable is the general consensus. It was gigantic, one of the last and largest pterosaurs, and its body was built to combine ground and air in a way that almost does not exist today. And the environment adds its own share to the should not have existed feeling. In environmental reconstructions of the Javelina Formation, Q. northropi appears rare and associated mainly with river channel facies, which fits with the idea of a more solitary animal tied to riverine habitats, not necessarily living in flocks like a colony of birds. In other words, it was not just enormous. It was enormous and quite possibly did not need to live in groups to survive. That makes it more unsettling because solitary giants tend to dominate by presence, not by numbers. 5. Kelenken guillemois. If I say predatory bird, your brain probably jumps to an eagle, a hawk, something that kills from the air. Kelenken guillemois was the opposite, a giant carnivore that did not fly, built to dominate the ground. And that is where the feeling of this shouldn't exist begins, because the idea that the top predator is a running bird, with an enormous head and a beak as its main weapon, feels bizarre, until you remember where and when it lived. Kelenken appeared in the Middle Miocene around 15 million years ago in Argentine Patagonia and belonged to the Phorus racidae, the famous terror birds. In South America, for much of the Cenozoic, this group occupied a role we now associate with large cats and canids, high-level terrestrial predators, with different sizes and strategies within the same lineage. One of the best parts of its story is the origin of the name, because it sounds tailor-made for a documentary. Kelenken refers to a spirit from Tehuelche mythology represented as a gigantic bird, and the species name guillemois honors Guillermo Aguirre Zabala, the student who found the fossil near Comalo in Rio Negro. The formal description arrived in 2007, based on a holotype that included something incredibly valuable for these birds, a very complete skull, along with leg bones and a toe. And here comes the fact that changes your expression. Kelenken's skull exceeded 716 millimeters in length, that is more than 701 centimeters just for the head. For a bird, that is absurdly large. That is why many popular accounts present it as the bird with the largest head ever recorded, or at least one of the largest known. Now, what does it mean to have a head like that in an animal that does not fly? It means its body was built around a single idea: run, catch, and finish the job. Forus racids in general had reduced wings, not useless but far from functional for flight, long legs, and a neck that worked like a lever. In Kelenken, that package was taken to the extreme. If the head was a tool, the neck was the mechanical arm that operated it. The place where it was found also helps make sense of this. The fossils come from outcrops of the Colonne Coura Formation, famous for its volcanic sediments and continental environments ranging from rivers and alluvial fans to lakes. In other words, this is not the setting of a cliff hunter, but that of a predator patrolling plains, shorelines, and open areas near water with enough space to exploit speed. And timing matters too. Around that period, there was a globally warm phase, the so-called Middle Miocene climatic optimum. It's not that heat creates monsters by itself, but it can support productive ecosystems with abundant prey and complex food webs. For years, the image of the crushing beak was repeated, as if it worked like a press. But biomechanical studies on a smaller Forus racid, Andalgalornis, showed something more nuanced. The skull resisted forces applied from top to bottom, that is, in the vertical plane, quite well, but was more vulnerable to lateral forces. Translated into behavior, this means that instead of wrestling with a large prey animal thrashing side to side, it was safer to attack with controlled, hatchet-like strikes and then withdraw the beak, a movement known as pullback, to reposition. With Kelenken, we don't have a video, of course, but we can cautiously apply that logic. In giant Forus racids, it has been proposed that skull anatomy tended to become more rigid, less flexible in certain regions, precisely in connection with a strategy of delivering powerful impacts with the beak. So the most realistic mental image is not that of a bird that bites and holds on like a feline, but of a predator that runs, catches up, and delivers one or several devastating blows to destabilize or kill quickly before the prey has a chance to turn the fight into chaos. And here comes the unsettling part. An animal like this does not need fangs. It needs precision and power. A large beak combined with a strong neck can function like a hammer, and because Kelenken was a runner, it could also turn a chase into attrition, forcing you to run across open ground until you make the mistake of stumbling, slowing down, or turning poorly. What prey did it have available? In Miocene Patagonia, there were native mammals of all kinds, and the very context of the Colonne Coura Formation shows a continental mosaic of rivers, lakes, and plains capable of supporting diverse fauna. There is no need to imagine it killing giant things for it to be terrifying. A predator of this size can thrive by hunting medium-sized prey, juveniles, weakened animals, or by striking opportunistically when it has the advantage. In fact, the literature mentions Kelenken as one of the largest Forus racids described, and high body mass values have been proposed in reconstructions, figures that circulate widely. But those numbers depend heavily on how the skeleton is completed from relatively few bones, so the most honest approach is to stick to what is certain: an enormous skull, legs designed for terrestrial locomotion, and a clearly predatory role. So why does it fit perfectly into creatures that shouldn't have existed? Because it breaks a mental agreement we have with modern nature. Today, large birds tend to be herbivores like ostriches, scavengers like condors, or aerial hunters. Kelenken proposes a different rule. I can be a bird, I can be giant, and I can be the dominant predator without flying. And on top of that, its name whispers that even local cultures, centuries later, imagined giant birds as mythical figures. If you saw it from a distance, it might not look like a monster. It would look like a tall, fast animal with a strange silhouette. But the detail that would freeze you is the head, that long beak, that structure not made for pecking seeds, but for functioning as a weapon. And in an open environment where there are no dense trees to protect you, a predator like that does not need to hide much. It only needs to see you first. And worst of all, Kelenken was not an isolated exception. It was part of an entire family of terror birds that for millions of years were a living reminder that the South American Cenozoic had its own apex predators. And some of them had feathers. 6. Chalicotherium goldfossi. If someone showed you a silhouette of Chalicotherium goldfossi without explaining anything, you would probably say, "That's a badly assembled horse." And I wouldn't blame you, because at first glance it looks like an ungulate, but with absurdly long arms, an odd posture, and to top it all off, claws. Real claws, not hooves. And that is unsettling because from a young age we are taught that large terrestrial herbivores follow more or less fixed rules, column-like legs, hooves to run or support weight, and mouths designed to crop grass or browse leaves. Chalicotherium, on the other hand, was a perissodactyl, a distant relative of horses, rhinos, and tapirs, that threw the manual out the window and assembled a body plan that looks like it belongs to a completely different group. To place it in time and space, Chalicotherium was a Miocene genus in Europe, with close relatives in other regions, and the species C. goldfusi is the type species originally described in the 19th century from material found near Eppelsheim in Germany, in deposits known as the Deinocheirus sander. In other words, this is not a single stray bone. It is an animal distinctive enough to build a full identity around its remains and keep expanding it with new discoveries. Although it was an herbivore, Chalicotherium was adapted for browsing, that is, feeding on leaves, shoots, and soft vegetation, rather than grazing like a cow. What is truly strange is how it did this. Its forelimbs were long and heavily armed with claws, with phalanges ending in large curved nails, and for that reason it is interpreted as having walked on its knuckles to avoid wearing those claws down. Yes, a large herbivore that walked like a gorilla to protect its own claws. And what were those claws for? Not for hunting, but for pulling branches closer. The general idea is that it used those long arms to hook branches and draw them toward its head, stripping leaves with its lips and mouth, as if it had a built-in rake in its hands. That also explains why the whole package feels so unnatural. It is as if it evolved to cheat height without needing a giraffe-like neck. It had reach forward, not upward. And if that already sounds strange, there is another anatomical detail that borders on quiet science fiction. As it matured, it appears to have lost its upper incisors and canines, with feeding relying heavily on muscular lips and a sort of gum pad, while the molars, more squared and low-crowned, processed the plant material. It was not an animal built for aggressive biting. It was a specialist in manipulating and grinding relatively soft vegetation. There is evidence suggesting that these animals could sit back on their haunches for long periods, probably while feeding, using the body almost like a tripod, weight supported at the rear with the forelimbs free to pull branches. This interpretation is supported by features of the ischium and other skeletal adaptations. If you visualize it, it becomes even stranger. A horse that sits down to eat like a large bear or a ground sloth. And here the inevitable comparison appears. Chalicotherium shows convergences with animals that are not its close relatives. It has been compared, in lifestyle and anatomy, to ground sloths, great apes, even bears in certain aspects, and also to a very strange group of theropod dinosaurs, the therizinosaurs, which were also herbivores with enormous claws. When evolution arrives at similar solutions in different lineages, it is usually because the problem was similar. Reaching vegetation, manipulating it, and defending oneself without relying on speed. Now let's talk about diet with a bit more substance. This is not just a guess based on shape. Studies of dental wear, known as microwear and mesowear in C. goldfusi, support the idea that it was a browser and that its diet could include twigs and bark in addition to leaves. This fits with the idea that it did not live in open grasslands like a modern horse, but in environments with enough trees and shrubs to sustain a reach-based feeding strategy. Chalicotherium shows that an herbivore can need claws for completely different reasons, and that being large does not always mean being a plains runner. You could be large and still live by mechanics, reach, and manipulation. There is also a psychological component. When we think of herbivores, we tend to imagine them as prey. An animal with enormous claws, by contrast, triggers an automatic alarm. And in the Miocene, that alarm would have been reasonable. A strike from a forelimb like that did not need to kill to be a deterrent. Injuring would have been enough. The sense that this doesn't fit is also reinforced by the group's distribution and history. Chalicotherium, the family as a whole, appear as a very peculiar lineage within the perissodactyls, with species on different continents over time, but always with this body plan that feels perpetually out of place when compared to horses and rhinos. 7. Nigersaurus taketi. If up to now we've been dealing with predators that are frightening because of their size or their weapons, Nigersaurus taketi is frightening for a different reason, because it looks like a dinosaur designed to break your intuition. You expect a sauropod to be long neck, huge body, relatively simple head. But this one, when you really look at it, feels more like an experiment in biological engineering. An extremely lightweight head, a shovel-wide mouth, and an absurd number of teeth. We are in the early Cretaceous in what is now Niger, in Africa. At that time, this region was not today's Sahara. It was a landscape with river systems, plains, and enough vegetation to support large herbivores. And there appears this Ribachysaurid, a member of the great sauropod group, but with a completely different style from the classic titans. The first thing that makes you do a double take is the skull. Nigersaurus had a head that, compared to its body, looked almost fragile. Not fragile in the sense of poorly built, but in the sense of being extremely lightweight, with thin bones and large openings. As if evolution had said, I don't need an armored head, I need an efficient head. And that efficiency was concentrated at the front. The snout was wide, very wide, like a flat nozzle. But what is truly strange is that its dental battery was arranged almost like a tool. The teeth were clustered at the front of the mouth in a very specific zone, rather than distributed along the entire jaw, as in most animals. Now comes the detail that makes it legendary. The number of teeth. It wasn't just, it has many teeth. It has so many teeth that it feels excessive. Between teeth in use and replacement teeth within the jaws, we're talking about hundreds. And the most impressive part is that they weren't there for show, they were there because they wore down quickly. Nigersaurus was a vegetation processing machine. To understand it, imagine an animal the size of a small bus, but with its head held relatively low without needing to lift it much. Instead of tearing high branches like a prehistoric giraffe, Nigersaurus seems to have been a low-level feeder. Plants close to the ground, shoots, ferns, soft vegetation. Its wide mouth could sweep a large swath of vegetation with each movement as if it were mowing the lawn, except without modern grass, because grasses as we know them today did not dominate the world the way they do now. And here comes the part that makes it even stranger. In many reconstructions, its skull is shown with an orientation suggesting that the mouth and teeth were perfectly positioned for feeding close to the ground. This meant that it wasn't just capable of doing this, it was probably specialized for it. Instead of being the typical sauropod you imagine browsing high up, this one looks like a ground-level vegetation vacuum cleaner. A wide mouth, teeth at the front, and a feeding style that was repetitive, constant, and high volume. Not because it literally vacuumed plants, of course, but because the ecological effect was similar. It consumed continuously and massively whatever was within reach. Another interesting detail is how quickly it replaced its teeth. In many herbivores, teeth last a long time. In Nigersaurus, the general idea is that the teeth wore down so frequently that replacement had to be very rapid. This is the kind of adaptation that only makes sense when your diet involves constant abrasion. Plants with abrasive particles, dust, sand, or simply the repetitive act of pulling up and processing plant material near the ground, where sediment inevitably gets mixed into the food. And that tells you something about the ecosystem. This animal did not live in a clean garden. It lived in a world where eating meant swallowing part of the ground along with your salad. So the solution wasn't be delicate. It was to create a system where losing teeth was normal, as if the body was saying, don't worry, I've got replacements. It's important to keep in mind the contrast with other sauropods from the same continent or nearby time periods. Some were tall, with enormous necks, seeking food higher up. Nigersaurus, by contrast, may have occupied a different niche, that of the herbivore that cleans up low vegetation, taking advantage of what other giants don't prioritize. That reduces direct competition. If you eat what's stuck to the ground and another eats what's high up, you can coexist more easily. And here comes the inevitable question, why don't we see something like this today? The short answer is that we do see similar designs among modern animals, but not identical ones. The modern world has herbivores specialized in grazing at ground level like cows, horses, and wildebeest, and it has animals with wide mouths adapted to cutting large swaths of vegetation. But Nigersaurus was an extreme within an extreme, a sauropod, a lineage famous for long-necked giants that decided to become a specialist of the lowest layer of the ecosystem, with a head so specialized it looks alien. And the nicest part, narratively speaking, is that its weirdness isn't it has a giant claw or it's as tall as a building. Its weirdness lies in the fact that it's a design of efficiency, almost industrial. Like those animals that don't scare you because of ferocity, but because of how strange it is that something so specific evolved and worked. If you could see it in its environment, the scene would probably be less epic and more unsettling through repetition. Nigersaurus walking slowly, head down, mouth sweeping vegetation, biting again and again with a constant grinding sound. Nothing heroic, nothing theatrical, just a biological machine doing its job. 8. Pegomastax. If Nigersaurus seemed strange to you because of its industrial design, Pegomastax will seem strange because of its personality. Because this dinosaur was small, yes, but it had a face that looks designed to confuse. A beak at the front, prominent fangs, a deep jaw, and in many reconstructions a sort of bristly look that makes it resemble a grumpy cartoon animal. Except it was real. We are in the early Jurassic in southern Africa. And the first curious fact is that Pegomastax was not a new discovery in the classic sense. The fossil was collected during an expedition in 1966 in what was then the Transkei region of South Africa, but the animal was not formally described until 2012, when paleontologist Paul Sereno named it as a new genus. That delay is not as unusual as it sounds. Entire museum collections contain material that sits for decades waiting until someone studies it in depth or until new comparisons make it possible to understand what it actually is. In this case, what was available was a partial skull with very informative elements, especially the lower jaw and the teeth. The name Pegomastax comes from Greek and means something like strong jaw, which already tells you what its defining feature was. This was not a delicate little dinosaur, but a compact animal with a chewing apparatus built to do real work. In fact, it is placed within the Heterodontosaurids, a group of small ornithischian dinosaurs characterized, among other things, by having differentiated teeth, hence heterodont, meaning different teeth. And what does different teeth mean in practice? It means that unlike many herbivores that have a more uniform dental battery, these animals could have a combination of beaks, slicing teeth, and in some cases, fangs. And Pegomastax had one of those front fangs that is especially striking. Why would an herbivore have fangs? The honest answer is probably for a mix of functions. Later discussions have suggested that in Heterodontosaurids these fangs may have served for defense, display, such as threatening postures between individuals or sexual selection, or even to help with certain types of food. And the important point is this: having fangs does not automatically make it a carnivore. In fact, the wear patterns and contact surfaces of its teeth support a primarily herbivorous diet, with jaw movements adapted to processing plants. Pegomastax feels like a puzzle with crossed pieces. It has a beak like an herbivore, specialized teeth for grinding, and at the same time a fang that in a modern mindset feels reserved for predators or animals that fight aggressively. In terms of size, it wasn't a giant either. It is usually described as a small dinosaur on the order of tens of centimeters, roughly the size of a domestic cat or a small dog, depending on the reconstruction. A commonly cited estimate in popular accounts is around 60 centimeters in length, though the key is to understand it as small and light, not as a large animal. Many reconstructions show it with bristles or filament-like coverings on the body. Where does that come from? From the fact that within the Heterodontosaurid group there are species with evidence of filamentous structures, such as Tianyulong in China, which opened the door to imagining that other relatives may have had something similar. But in the specific case of Pegomastax, the known material is mainly the skull and jaw. There is no direct evidence of preserved skin or feathers in the type specimen. So the correct approach is to treat that feature as a plausible reconstruction, not a certainty. It had a deep, projecting predentary bone at the front of the lower jaw, suggesting a mouth with a very particular profile, almost like a stout little beak. And when you combine that with the idea of a fang and grinding teeth, you end up with an animal that doesn't fit the dinosaur stereotype. It's not a mini velociraptor, and it's not a mini triceratops. Its genre would be, what on earth is this? 9. Deinocheirus mirificus. For almost half a century, Deinocheirus mirificus was the perfect dinosaur for the imagination to run wild. Not because much was known about it, but because almost nothing was known. And what little there was impossible to ignore. 2 gigantic arms, about 2.4 meters long, found in 1965 in the Gobi Desert, Mongolia. With that alone, it was inevitable that all kinds of theories would arise, that it was a super predator, that it was some kind of strange prehistoric sloth, that it belonged to an unknown lineage. Science, for once, had to admit, we don't know what it is, but those hands are terrifying. The name fit perfectly. Deinocheirus means something like terrible hand, and mirificus refers to the astonishing or unusual. And it wasn't just for show. Those arms came with part of the shoulder girdle and a few scattered bones, but the rest of the body was missing. In 1970, the genus was formally described based on that material, and from then on it became a famous ghost in paleontology. Everyone knew it. No one could fully describe it. The story took a dramatic turn when two new specimens appeared in the Nemegt Formation, excavated in 2006 and 2009, and here comes an uncomfortable but real detail. Fossil poachers had already passed through at least one of those sites. When the team arrived, they found much of the skeleton, but key sellable pieces were missing, such as the skull and elements of the hands and feet. Even so, what remained was enough to connect the dots, and the stolen pieces eventually resurfaced later on, allowing the puzzle to be reconstructed far more completely. It's the kind of story where science moves forward, but also reminds you that a black market is destroying information forever. And when the animal was finally seen as a whole, the result was even stranger than anyone would have bet on. Deinocheirus turned out to be an ornithomimosaur, that is, part of the ostrich dinosaur group, but taken to an extreme, gigantic, heavy, and not at all built for speed. Instead of a light, fast body, it had a robust build, wide hips, relatively shorter hind legs for its size, and the general look of a large animal that doesn't need speed to survive. One reconstruction based on the new fossils estimated it at around 11 meters long and over 6 tons in mass. The face was another shock. It didn't have the typical sharp head of a predatory theropod. It had an elongated snout and at the tip a shape many people describe as duckbill-like, broad and suited for gathering food rather than tearing flesh. And on top of that, as if something else were needed to complete the absurdity, it had a back with tall neural spines forming a kind of hump or sail. In other words, a giant ostrich with a hump, monster arms, and a wide beak. The part that makes it even more disconcerting is the diet, because with those arms and that size, you'd expect a predator. But the evidence pointed elsewhere, a mega omnivore. In the abdominal area, more than 1,000 gastroliths were found, small stones swallowed to help grind food, and in addition fish remains associated with the stomach contents. That doesn't sound like a classic carnivore or a pure herbivore. It sounds like a massive animal that ate whatever the environment offered, including plants and aquatic resources, and the environment fits that idea. The Nemegt Formation is interpreted as a system with river channels, floodplains, and lake zones, a wetter landscape than other Cretaceous formations in the region. In that setting, it's easy to imagine Deinocheirus moving along shorelines, lowering its beak into shallow water, searching for soft vegetation or small animals, and using its sheer size as protection against the large predators of the area. It wasn't a sprinter, it was more like a strange tank adapted to a world of rivers and mud. 10. Estemmenosuchus mirabilis. Before the famous dinosaurs existed, before cinematic roars and postcard fangs, Earth already had creatures that looked as if they had been invented by someone with bad taste and a lot of imagination. Estemmenosuchus mirabilis is one of them. A large, heavy animal with a reptile-like posture, but in reality closer to us than its face would suggest. It was a therapsid, part of that great evolutionary line of synapsids that would eventually give rise to mammals, and yet the first thing that grabs you is not its family tree, it's its head. Because Estemmenosuchus had a long, massive skull, up to about 65 centimeters, crowned by a set of bony protrusions that look like horns or antlers projecting upward and sideways. It's as if it were wearing an irregular crown, a war helmet, or a permanent costume. That's why its name in Greek is often translated as something like crowned crocodile. The second reality check is the time period. Estemmenosuchus mirabilis lived during the Middle Permian, around 267 million years ago. That places it in a world that feels almost alien. There is no modern grass as a dominant feature, no birds, no flowers. And terrestrial life was ruled by groups that no longer exist, with names that sound like spells. Deinocephalians, Biamosuchians, Paraeosaurs, Dicynodonts. Its address is also very specific. Fossils of Estemmenosuchus are known from the Perm region of Russia, specifically the area near Okhyor-Oka, in deposits associated with the Belebey Formation and a local faunal zone. And an interesting detail, it's not just that one was found. Several complete and incomplete skeletons have been reported in accumulations, suggesting episodes in which multiple individuals were buried in the same sedimentary context. Now comes the part that places it squarely among creatures that shouldn't have existed. Estemmenosuchus seems built out of contradictions. It has the face of a strange predator with that ornamented head and an imposing jaw, but it is interpreted as an herbivore or early omnivore, an animal that could eat vegetation and possibly supplement its diet with other resources. It has horns, but they are not horns like a bull's with a core and sheath. They are bony growths of the skull, more like permanent display structures. So, what were those crowns for? The most accepted explanation is also the most human: to be seen, to communicate. It has been proposed that these structures were used for intraspecific display, for recognition, intimidation, or signaling a particular status, and perhaps also in competitive behaviors like pushing or controlled clashes, without necessarily implying fights to the death. In other words, it didn't wear that crown to hunt, it wore it to survive socially. And that's what makes it so strange. Because we're used to extra features on the head indicating natural weaponry, like horns for defense or fangs for killing, in Estemmenosuchus, the extra seems more like a flashing sign. Here I am, look at me, I'm strong, or I'm an adult. Then there's the body. In typical reconstructions, it's shown as robust, with relatively short legs, and a posture that isn't that of a modern mammal with limbs tucked under the body, but rather a somewhat sprawling or semi-sprawling posture, inferred in part from how its shoulder joints fit together. That adds to the unsettling effect. It looks like a hybrid between a large reptile and a primitive mammal, as if it hadn't yet decided which style of locomotion would dominate the future. In size, it wasn't small either. It's often stated that it could exceed 3 meters in length, placing it firmly in the category of, if it's in front of you, don't doubt it. This thing has weight. And even if it wasn't a top predator, an animal like that doesn't need speed to impose presence. In a Middle Permian ecosystem, sheer mass and a head armed with extra bone are already a strategy. To understand the fragile habitat in which this animal lived, we need to transport ourselves to a Middle Permian riverine plain on an Earth that was still assembling toward the supercontinent Pangaea. There are water channels, sediments, vegetation of conifers, and other ancient plants. In that landscape, the Deinocephalians, the group to which Estemmenosuchus belonged, were part of a dominant fauna for a time, until things changed abruptly. And understanding this is fundamental because Estemmenosuchus existed in an era where terrestrial life had already experimented with large forms, but was still vulnerable to profound crises. There is evidence of a significant extinction event in the Middle-Late Permian, often associated with the Capitanian event, which affected both marine and terrestrial ecosystems, and during which the disappearance of groups like the Deinocephalians is discussed. Some studies link it to large volcanic episodes and environmental changes on a broad scale. Put simply, Estemmenosuchus belonged to a kingdom of creatures that dominated for a while and then faded out. And narratively, that makes it even stranger. It wasn't just rare because of its anatomy. It was rare because it represented a world that left no direct heirs with that same style. The line leading to mammals continued, yes, but that Baroque crowned head aesthetic remained as a Permian experiment. With Estemmenosuchus, we're not talking about physical impossibility. We're talking about something subtler, how hard it is to accept that evolution doesn't only produce practical animals, but also theatrical ones with exaggerated structures that make sense in their social and ecological context, even if they seem excessive to us. Because if you think about it, Estemmenosuchus mirabilis looks like an animal designed to frighten, and yet its most obvious weapon may have been, above all, a language. A system of signals in bone carved permanently into the head, declaring who it was in the group, what place it occupied, and how dangerous it was to mess with it. And the most unsettling thing is to imagine it walking, heavy, patient, with that impossible crown silhouetted against a birdless sky in a world where life was already large, strange, and at times brutal. millions of years before the first famous dinosaur appeared.